main objective behind the CB machine is to allow us to make our own custom plates for any build that we have in mind. The big limit was always, where can I get these plates made? Where can I get these plates done? Well, we no longer have to worry about that. We make our own plates now. We have the software to do it. We have the machine to do it. So the CB machine really does fill a gap. Now you can design your own plates and create your own machines without any need for specialized services. Besides making your own gantry plates, you can carve all kinds of cool stuff. We have some carvings out of aluminum here. This is oak. You also have MDF, just standard foam carvings, plexiglass plates, all kinds of 2.5D milling. Here's 3D milling of a ripple. Just amazing what you can do with this machine. So go ahead and follow through with the video. Build this machine. You'll be able to cut out all kinds of great things and let your creativity loose to just make anything you can imagine. We hope you enjoy. Thanks for watching. So I just wanted to give you a quick overview of the CB machine. It's a really cool setup. Let me hide this real quick. Here's the actual model of the machine itself that you can dissect and go through and kind of edit and modify for your own. You can see by the pictures here that it's made up of 3 linear actuators, X, Y, and Z. It's also built as simple as possible and uses all stock parts from the OpenBuilds part store. The CB machine is based off of machines that we have seen around the internet that are designed specifically for milling plates, and that is where the CB machine shines. On this particular setup, you can see we have the axis orientation as well as an example table built that houses both the laptop as well as a place to put the vacuum. And also we have plexiglass side plates. We'll be posting that as well as any other software that we use or any example G-codes that we use for this build. So all this will be available. So I hope you like it and you enjoy the build. Alright, we'll get started by building the C-beam gantry plate. I have an example here to give an idea of what it looks like and what it consists of. You can see we have a little piece of C-beam here, as well as the C-beam gantry plate, which consists of 4 mini V-wheels, as well as the lead screw nut block. And on this plate we have 2 sets of screws that have eccentrics on them that allow you to adjust them tighter to the rail, and then 2 sets of screws that are just locked in with standard spacers. So this is pretty much makes up what the C-beam gantry plate is. We'll go ahead and build that now. So on the first steps, what we're going to do is attach the wheels to the gantry plate, and you'll notice that you have the larger side here where the holes are larger. This will be for the eccentrics, and then this side here with the recesses will be for the standard spacers. So one of the things I wanted to show first, I have a mini V-wheel sleeve here, and I just wanted to show how to build one. It's real simple, just take one of the bearings, push them in one side, one of the precision mini shims as our spacer between the 2 bearings, and then the last bearing, and you just sandwich that together, and that completes making the mini V-wheel. So go ahead and make up all 4 of those and lay out your parts like you see here. These are 25mm screws. We have 2 of the 6mm eccentrics like you see here, as well as 2 6mm aluminum spacers. So to start things off, on the side that just has the recesses without the larger hole where our standard spacers will fit, we're going to go ahead and just slide a screw through there. I'm going to put one of the aluminum spacers, one of the precision shims, the wheel, which sometimes helps if you spin them to get it on there, and then the M5 nut like you see here, and I'll just hand tighten that. Same thing on the other hole here. We're going to go ahead and slide the screw through. If the screw sticks out a little bit, don't worry about it, because when we tighten it down, it'll seat itself in there. Standard spacer, precision shim, the wheel, M5 nut, and that's basically how that is. Now when we get to the eccentric side, go ahead and take your eccentric and slide it in the hole like you see here, and you can see as you adjust it how you'll be able to move this whole wheel assembly in and out, away from and into the rail system. So I'm just going to push the screw through there, and again with the precision shim, a wheel, and an M5 nut. So it should look something like that. Do the same thing on the opposite side. Okay, that looks good. One of the things you could take note of is there should be a 6mm mark showing you the furthest point of the cam. So I'm going to go ahead and just tighten these wheels down. My 8mm wrench here and the Allen. Okay, that's tight. There's no movement there, so that's good. I'm going to do the next one. Okay, that one's good. Now those are both the standard. Make sure they roll well. And then on the eccentrics, do not over tighten those because we still need to be able to adjust the eccentric once we have it in position. So these I'm just going to snug. Just kind of get them in locked in place there. And find your 6mm mark and kind of just, I'm going to actually point that 6mm mark out to the halfway point. Let's see if I can find that on here. And that looks good. So you can kind of see I have one pointing that way and one pointing that way. That looks really good. Okay, bring in the 250mm piece of C-beam that you have. Make sure that the tracks are clean on the inside here. And what we're going to do is set the preload for these eccentrics. And what that means is we're basically going to set pressure against the rail so that there's no movement. We're going to need to turn the eccentrics out towards the rail a little bit at a time here. So I'm just going to turn it out that way a little bit, and I'll turn this one this way a little bit. Okay, so for the sake of the video, I added a little mark so we could see where the eccentrics are, and I'm just going to put that in there. You could see there's a lot of preload tension on there. Let's spin it around this way. A lot on there as well. And you can see that we have a good amount on there, and it's not easily falling up and down, but it's nice and tight. And that looks good. I'm going to go ahead and tighten the two eccentrics down now. And a lot of times after you tighten this down, you still need to adjust the eccentrics a little bit more. So adjust the eccentrics so that they're pretty much even on pressure, and make sure they're nice and tight. You can check that by pulling up and down on here, just making sure it's nice and tight. All right, that looks great. Let's move on to the next step. On this step, we're going to be adding the lead nut block, and we're going to start off by putting the M5 nut into the corresponding holes that you see on the nut block. Just like you see there. And we're going to take our plate off of here. Go ahead and you're going to, on the middle two set of holes that you see here, you're going to put your two 20mm screws. Just put your fingers on there to hold it. And you're going to be putting your 3mm spacers on top of that, like you see. And then you're lightly going to put the nut block right there. And while you're holding that in place, go ahead and kind of tighten that down. Now, on these nut blocks, you'll see that the metal M5 nut here has nylon in it. So when you get to a certain point, it gets a little hard to tighten down. So what we're going to do is we're going to tighten it down a little bit to get into that nylon a little. And then we're going to back it off. And you can see, you can hear there's movement there. So what you want to do is, I like to just put that on the ground like that, push my thumb on it, and then tighten it down to where you're just snugging it in place, but you're not doing anything to distort the plastic. And make sure that it cannot move. And that looks great. Go ahead and make sure it fits. Everything works. Everything fits. It looks great. See here, it's nice and tight. All right, it looks great. Let's move on to the next step. So now we're going to work on the x-axis. And this is a V-slot gantry plate. You can see that I've already gone through and I've attached 3 of the solid V wheels. You can see that we have the 6mm spacers as well as the 1mm shims underneath of each one of these. And on the bottom side here, we've attached the 6mm eccentrics as well as the shims here. So I just wanted to leave the last one off to kind of show you how it goes together. First of all, again, to build the wheel, the mini wheel and the larger solid V wheel works the same way. The bearing on one side, spacer in between, just like that, kind of presses together. Put the screw through the bottom. Now you can see we have the larger holes, and these are for the eccentrics. Eccentric with the lip facing in, locks into that hole there. And I've got the divot of the eccentrics all facing this way for now. They're going to be adjusted to the rail. Go ahead and put the shim on and then the wheel. And sometimes it helps to spin it. It'll go on a little easier. M5 nut. And again, since these are the eccentric side, you really just want to snug them because we still have to adjust the eccentrics. So go ahead and build what you see here, this whole assembly, and from there we'll move on to the next step. Alright, let's go ahead and install the lead screw nut block, and it's going to install on these 2 holes that you see here. It's going to be positioned just like this because the beam will run through here. So let's go ahead, and I've got our screws here. We're just going to put them through, hold them from the back there, 3mm spacers. Put those on and go ahead and put the M5 nut into the nut block like you see here. We'll lightly put that on, and just like the last one, we'll tighten it down into the nylon of the nut here, and then we'll back it off. Okay, so I have this a little bit loose like you can see here, just like we did last time. Put this on the ground here and kind of just put my thumb on it while I snug it in place. You don't want to over tighten this because it can distort the plastic, and there's no need to over tighten it. Looks good, and we're nice and tight there. Let's move on to the next step. At this point, locate one of the 500mm C-beams. This is the C-beam that we are going to use for our X-axis, which will be our left to right axis. And we're going to introduce the V-slot gantry plate that we just built to it. Go ahead and slide that on. Should go on to the first set of track here. And you'll notice that it's very loose. The standard spacers side we are calling the top of the gantry. So the gantry would sit like this on the machine. And the eccentric side that you see here will be the bottom of the gantry. We're going to go ahead and turn these eccentrics until they seat onto the C-beam. So just slowly turn these until you feel them just touch. We still have to bolt this plate to another plate. So this one I can feel is just a little bit of friction there. So now I'll turn this one. I'll do the middle one last. So there's a little bit of friction here. Just something to hold them on. The last one I'm going to turn to the right a little bit until we feel it catch. And just keep adjusting all 3 of them until they feel about the same. But don't over tighten these. We just want to get them kind of loosely on there with not a lot of preload at all. Like I said, because this will bolt to the Z axis, and once we do that, we're going to have to adjust these again anyway. So that looks good. Just kind of get yourself locked on there loosely like you see here. Let's move on to the next step. On this step, we're going to take our V-slot gantry plate and mount it to the Z axis, which is the 250mm C-beam. This will make up the X axis that goes left to right, and our Z axis will ride up and down in the center of the C-beam. So in order to do this, you can see that we have the screw head sticking out here. In order to mount this plate flush and ensure that it's one strong solid connection with the C-beam, we're going to be using some of the slot washers, which will allow us to mount this flush as well as keep the spacing that we need. Looking at the V-slot gantry plate here, you'll notice you have a lot of holes here as well as here. And these are the holes we're going to utilize. With our 10mm screws, going to set this on here and just drop these in place so you can see where they're going to go. So you can kind of see how it's going to be set up here. This will make a really strong connection. So the first thing we want to do is take some tape and secure these screw heads in place. All right, I have a little bit of painter's tape here. I'm just going to put that like that. Just kind of hold these in place. Okay, those are all taped on. Everything looks good there. Let's go ahead and put the washers on. Should look something like this. And we'll go ahead and put our T-nuts on. We're just gonna tighten these down a little bit, just enough so they hold, maybe 1 or 2 turns. We're lining them up long ways so that we can slide this on here. Okay, so you can see we have the T-nuts on. They're all lined up like you see here. And we're going to go ahead and just slide the C-beam on here, carefully aligning everything. Just like you see there. That looks good. At this point, we're going to go ahead and take the tape off. And with the V-slot gantry plate lined up to the edge of the C-beam, turn it down like this. Go ahead and just tighten these down. All right, so we have those all tightened down. Now I'm going to go through and just wrench them a little bit more, make sure they're secure. Okay, that looks great. The V-slot gantry plate is one now with the C-beam, and it'll make for a really strong connection on our X-axis. So let's move on to the next step. On this step, we've reintroduced the 500mm C-beam that we're going to use on the X-axis. We want to slide the assembly that we made on here, and we want to adjust the eccentrics accordingly. So we're going to go ahead and put this on now. It might be a little bit tight because we've compressed these wheels, but just make sure that it's really nice and tight, and that you can see here, if I try to turn these, I can barely turn those wheels, by hand. I can spin them a little bit, but they're nice and tight. There's no play whatsoever between the two. That'll make for a really nice strong connection, which is what we're after. You're going to want to go through, just double check that you have everything tight. Make sure you have a nice tight connection here. If not, just go ahead and tweak it, get it where you want it. At this point, tighten down the eccentric nut there so that everything is tight to the plate now. If you need to, you can loosen these and scoot them back to get the screwdriver under here. You can also adjust this whole plate up or down so that your Z-axis can be lower if you want or higher if you want. You can just adjust it where you want. This is where we want it for now. This is a great starting point. We'll keep it there. You can go through, you can lubricate the wheels if you want and the lead screw. Any kind of tweaking that you want to get done, go ahead and do that now. And we'll go ahead and move on to the next step. Portion of the build, we're going to go ahead and assemble the Z-axis actuator. And you can see that we have all the parts laid out, ready to assemble. Here's one of the end plates. You see that it has a recess side for the 4 20mm screws. Go in just like you see here. And also has an opposite recess size that'll fit the 8mm bearing. One of the things we have to do before we get started is the lead screw is an exact fit for the bearings. We need to sand it down about 2 inches in on each end, just like you see this bearing able to fit, no problem. That's what we want. So I've already done it to this one, but I'm going to do an example of how I went about doing this. So just to give a quick overview of how to get the bearing to slide on nice and smooth, we're able to knock the end of the lead screw down a little bit using some fine grit sandpaper. And the way I do it is I chuck the lead lightly in a drill like this, and then just take some fine grit sandpaper, and you only want to go in about 2 inches on the end and just run it back and forth, swap it. Same thing on this side. What that allows is it allows a nice snug fit for your bearing on the end of the lead without side to side play. So go ahead and do that now, and once you have that complete, we'll continue with the build. Just double checking everything, making sure that your standard spacers are on the top as shown here. Your eccentrics are on the bottom. It's going to ride on the beam like this. So it'll hang from the top ones. And this will be the bottom of our Z-axis and this will be the top. So let's go ahead and we're going to go ahead and screw these in here. Crank those down, make sure they're in good. All right, now one of the things we're going to do is we're going to, just like you see facing here, I have the eccentrics on the right hand side here. Go ahead and slide that on. And make sure that your preload is nice and tight on both sides. It's really good, there's no play there. And we'll go ahead and screw the lead screw through. That looks good. Now we're going to take one of our bearings, slide that into the end here. We have our lock collar. Make sure the set screw is out far enough so you can slide it on. 8mm shim. It has a rounded side and a flat side. Make sure the rounded side is facing towards the bearing. Like you see there. We'll slide this whole assembly back. And just going to make it flush with the end here. Just like you see here. Slide the lock collar in place. We can actually go ahead and tighten that down. Let's go ahead and we'll put the top one on at this point. We're going to put the lock collar on. 8mm shim with the rounded side that'll be facing towards the bearing again. This one I'm just going to slide the bearing on. We'll go ahead and screw this down. Now on this one I have these, all the way tightened down. I'm just going to back them up a little bit so I can get a little bit of movement because I want a little bit of preload against this. So go ahead and put our bearing in place, our washer. And what I'm going to do is I'm going to have our set screws facing the same way and pressing against here. I'm going to go ahead and tighten that down. Tighten that down. What you're trying to do is just make it so that there's no up and down movement, no play there. There's no movement up and down there. Okay, that looks good. Let's go ahead and get our flexible coupling. Slide that on. And on this, you want to make sure that you leave about 1/2 millimeter, just so it's not scraping when it's turning. Just leave a little bit off of the edge there, away from the end plate there. You definitely want to tighten this down. You don't want any play here either. Okay. Make sure it's not hitting. You should be able to turn that pretty easily. That looks good. No movement there. All right. Last thing we're going to do is install the motor. And we have our two 40mm spacers, two 55mm screws. One of the things we're going to do here, they're going to mount right into these two threaded holes here. Since this is our Z-axis, I want to make sure that we have our wire facing in the right direction. Mine is going to come out of the back here. Then I'll be able to route it whichever way that we feel is best there. Go ahead and put the screws through like that. Kind of line those up. And then line up the shaft with the flex coupling. And something like that. Go ahead and tighten these down. Okay, that looks good. Now let's go ahead and tighten the motor shaft to the flex coupling. And again, you don't want this one to be loose because it can create play, so go ahead and tighten that down. That looks good. All right, that completes the actuator for the Z-axis. That looks really good. Let's move on to the next step. For this step, we're going to build the X-axis as well as attach our Z-axis assembly to it. So we'll go ahead and start building this actuator now. First, this one requires a couple extra features as far as mounting brackets. We're going to be mounting some of these 90-degree cast corners to it, so just something to keep in mind. First thing I'm going to do, make sure the track is clean, and we're going to go ahead and install our Z-axis assembly. Now, you want this to be tight, but don't forget later you can go back and adjust these eccentrics if need be. That's good. What I'm going to do is I'm going to install 2 T-nuts on this side here and 2 T-nuts on this side here in this back track here that you see. And these will come into play later. We also need to install, let me bring this up here, a T-nut here and here, and the same thing on the other side. Alright, and these will be for brackets later in the build. That looks good. Let's go ahead. Our motor is going to be on the right hand side of this particular axis. You could put it on either side, but on my build I like to keep it over to the right. On this side, what I'm going to do is, on this one, since this is the back side and I want the lead screw to be flush, I'm going to go ahead and mount the C-beam end plate to this side first. Go ahead and do that now. Just a word of advice, be careful when you're tilting the assembly around because the T-nuts will want to slide out. Let's go ahead and put the C-beam end plates on now, on this side. Now I'm going to take the lead screw, and again, if you haven't done it, go ahead and take some of that fine grit sandpaper. Make sure that your bearings will fit on here. I'm going to go ahead and find the nut block here. Well, that looks good. Put the lock collar on. Again, face the rounded part out of the 8mm shim. Put your bearing on. Making this flush to the end here. Okay, that looks good. Let's go ahead and start with this side. Again, I like to try to line up the set screws, just for looks really. Make sure there's no play. Okay, that looks really good so far. Let's continue. We'll put the flex coupling on. Again, leaving a small gap so it doesn't rub on the C-beam end plate. Really good. Make sure everything runs smooth. Again, make sure your track is cleared. And we're going to go ahead and install the motor. On this one, the wires are going to run back this way. So it's going to sit like this. Okay, that looks good. Let's go ahead and tighten down our flex coupling. If you get resistance when you're trying to turn it, just check your wires because you may have 2 coil wires touching. Makes it a little harder to turn. That's really nice. All right, that looks good. So that is our X and Z axis up to this point. It looks really good. Now you want to locate 4 of the cast corners. We're going to be putting 2 on each side of this particular actuator. And you're going to need 4 of the 10mm M5 low profile screws. And we're just going to go ahead and put these in position. You don't have to over tighten these because we'll have to adjust them. Just get them so they don't rattle around for the time being. When we go to put the columns on that the X-axis holds to, we'll be able to go through and adjust these. Go ahead and install these. All right, that looks great. Like I said, we'll adjust these later once we have the columns, so don't worry about their position. These also come later in the build. We'll be attaching a plate to these to hold to the top of the column. So up to this point, X and Z axis looks great. Let's move on to the next step. For this step, we're going to go ahead and mount the OpenBuilds spindle mount to the Z axis. First thing we're going to want to do is take some of our 90-degree corner connectors, and we're going to screw them right into the center holes, center two holes here on both sides. So let's go ahead and do that now. I'm using 10mm screws, and I'm just going to leave it flush like you see here, so that way when I mount it to the plate, it will be flush. So go ahead and mount all 4 of those now. Alright, so now we'll go ahead and mount this, and you can see that it lines up with these threaded holes that are already in the plate here. So you can see that that's loose, and I can go ahead and put all 4 of these in. And what I'm going to do is just pull it down towards me and snug those. And then we'll go back with the short end of the Allen and crank those in position. Now make sure you take the pressure off as you turn it. You don't want to twist your plate. Okay, that looks really good. Let's go ahead and for the time being, I'm going to mount the front plate on here as well. Alright, it's really starting to come together. It's looking sharp. Let's move on to the next step. In this section, we're going to be building the Y-axis, which is the table axis that moves front to back on the machine. So for this, we'll need the build plate. And you can see on the build plate, we have a couple sets of holes here. The holes we're concerned with are on the second row in from the outside edge. So this set here. And you have one side that has the eccentrics and one side that has the standard hole size. The eccentric side will allow us to adjust it to the rail. So go ahead and build 4 of the solid V wheels, and let's go ahead and get started with the build. So I'm going to start on the standard side. Just going to push a screw through here and just copy what we're doing here, and you can see how it goes together. So we have the 6mm spacer as well as a precision shim there. Let's slide the wheels on and the M5 nut. Just hand tighten that for now. Do the same thing on this one. I'm going to go ahead and tighten these in position. Okay, that's good. They're rolling smooth and they're locked in there, and we'll go ahead and do the eccentric side now. And of course we're on the last holes out here because we're using C-beam, which is 80mm wide. So kind of see how that goes. And on the eccentrics, I'm going to face the eccentric out this way, the cam, so that we can turn and adjust it in once we get everything aligned the way we want it. Precision shim, then the wheel, M5 nut. Go ahead and tighten this down. Now, again, you don't want to over tighten this because you want to adjust the eccentric. So I just have those snug right now because we want to later adjust the eccentrics. That looks good. Let's keep going. Okay, we're going to attach the nut block to the build plate, and we're going to go ahead and put our screws through the center, kind of see how it goes. So they go through these 2 center holes and then the 3mm spacers. I'm going to go ahead and put the M5 nut into the nut block. You can see there. Put these on top. And again, I'm tightening it down through the nylon and then backing it off until it's loose and I can feel it moving like so. And then I'm just going to hold my thumb on it, pressing down, and I'm going to snug it in place. And that's really good. It's not overly tight, it's perfect. All right, that looks good. Let's move on to the next step. Bring in the 500mm C-beam that we'll be using for the Y-axis, and just run your fingers down, make sure the outside track is clean. And what we're going to do is we're going to set the preload on the eccentrics, just so we have this plate where it should be. So we go ahead and install that now. And of course, right now it's loose. We're going to go through and tighten that to the rail. I'm just going to turn these out until I feel the wheel hit. And this one I'll turn out this way. That's nice and tight. I can barely turn the wheels. I'm going to take this off. Tighten down the M5 nut on the eccentric side because remember we left it loose. See the preload on there. No movement here. Okay, that's great. That looks really good. That'll be our Y-axis. So let's move on to the next step. All right, so later in the build, we'll be mounting our MDF spoiler board to the build plate here. And in order to do that, we want to be able to utilize these self-tapping screws. So on these outside holes here of the build plate, we want to go ahead and drill these out to 6mm so that the self-tapping screws will be able to just go through here and drill right into the MDF spoiler. So I'm going to go through now. Go ahead and just drill these out now, and that'll allow us to put those through later. So go ahead and follow through with that. Just make sure that you can slide the self-tappers through there. All right, that looks good. Make sure that you're careful on these edges because they can be sharp once you drill them through. That looks great. Let's clean up here and move on to the next step. It's not necessary, but if you have one of these recessing bits or a V-bit in general, you could chuck that up and go through and just knock some of these burred edges down. I'm going to go through and just lightly touch that on both sides of the plate, and that should help just smooth that out. Okay, that looks much better. You can see that it knocks any of those sharp chips off, so that looks really good. Let's clean up and move on to the next step. All right, I went to the hardware store and got a piece of 2x4 1/2-inch thick MDF, and I cut it down to 1 foot by 1 foot. You see here I made 2 of them. One will be our table and one will be the spoiler. They'll be sandwiched together like you see here. Just want to go ahead and do that now. Make sure you have a couple pieces. All right, so on this next step, what we're going to do is find the center of this board by going corner to corner with this C-beam as a straight edge or whatever straight edge you have. One of the things we have to do first though is remove the nut block from the build plate so we can gain access to the center hole for marking. So I'm just going to take these 2 screws out. It takes a second. So we'll just set that to the side for now. Go ahead and take your 500mm C-beam and draw a line straight across from corner to corner. All right, that looks good. This will be our center. Then we'll take our build plate, put it on just like you see here, looking for the center of the X in this middle hole. There it is, centered. And then you can measure from the edge to make sure you're square. Looks good. And then we're going to go ahead and mark our perimeter holes. And then I like to draw a box around the outside here, just in case we ever take it off. We have something to go by besides the center hole. We can easily realign it. All right, that looks good. You can see all of our markings here, so we can easily replace it. So that looks really good. Let's move on to the next step. On the next step, we're going to put the nut block back in place. So let's go ahead and do that. A couple screws, spacers, and put the nut block back on. Again, don't over tighten these, just snug them. Again, you can see I'm holding my thumb on here, just holding it down while I snug it in place. And just make sure there's no movement. That looks great. Let's move on to the next step. On this next step, what we're going to do is we're going to put spacers on all of the outside perimeter marks, and we're going to drill them in place with our self-tapping screws. And first thing we're going to do is line up the plate, as you see here. Try to line up the spacers the best you can. Okay, that looks good. Now we're going to go ahead and just go around and screw these in place. It may require drilling in and then backing out a couple times before you get it to seat properly. Just go slow. You don't want to strip it out. You just want it to grab and stay where it's at. Okay, that looks good. Just make sure that they're all seated. If you have to, just tighten it down a little bit more. That looks really good. Let's move on. All right, so now that we have the build plate attached to the work table, I'm gonna go ahead and turn this and clean this track out a little bit. And I'm just gonna put the C-beam on here just to make sure that everything is still tight, and that in case we need any adjustment on the eccentrics, and we do not. This is nice and tight. It's not going anywhere. That's great. All right, that looks good. So now what we're going to do is bring in the other piece of MDF, set it right on top, and this is going to be our spoiler board. So as we cut through parts, it's going to, cut into this board lightly. And over time, you'll have to replace this board. We're just going to have 4 screws that hold it in place, and we'll be able to take it off and put a new one on there at any given time without affecting our actual build surface. One of the things I like to do is mark, once I get this squared on here the way I like it, I like to mark the front. Just so when I realign it, I'll know where the front is. So at this point, I'm going to measure in about a 1/2 inch on each corner, and I'll put a dot there, and we'll drill some holes, and we'll put 30mm screws through here with T-nuts on the bottom. So the first thing I'm going to do is just measure in a 1/2 inch on each side. Okay, so I've measured in a 1/2 inch this way. Now I'm going to rotate this and measure a 1/2 inch this way, and that'll give us our point that we want to drill at. Okay, so where these cross will be where we drill. You can use a 1/4 inch or a 6mm drill bit, just enough so that the screw can go through. Just make sure everything's aligned. And you're going to drill through both sets, straight through both of these. Let's go ahead and do that now. All right, so I have my 1/4 inch bit in the drill, and I also have my little recessing bit, which I'll use to clean up the holes once it's complete. So go ahead and drill these out. All right, that looks good. We'll go through and clean this up, and we'll recess these holes out. I just want to mention that I'm going to recess this down on the top here a little bit so that we can get the head of the screw flush with the top of the spoiler board. And I also went through and just recessed the bottom holes a little bit just to make them look a little nicer. All right, so let's go ahead and clean this up. All right, so now we're going to line up the 2 halves, and once again we go by that front mark that we made, and we have some 30mm M5 screws. Just drop those in, and then we have some T-nuts. So just going to tilt this up and tighten the spoiler board in place. Looks good. Let's go ahead and tighten it down. All right, it doesn't matter if the screws stick out a little bit, that's fine. That looks really good. Nice spoiler board below the surface. All right, let's move on to the next step. All right, on this step, we're going to be putting the braces on that holds the Y-axis C-beam onto the frame. So what it's going to look like is as simple as that, just 4 braces, 2 on each side there. So what we're going to do is take 10mm screws, T-nut, slide it in place. It's going to go on the bottom rail here. You can see just like this. And for now, we're just going to temporarily keep them a few inches from the end there and Just put them in place like you see there. Just something like that. We'll do that to both sides. Okay, just like you see there, again, don't worry about where their position is at this point. We'll get to that later. All right, looks good. Let's move on. On this step, we're going to build the Y-axis actuator, and we'll apply the table to it once we get about halfway through the build. Let's go ahead. We're going to lay out our parts now. We're going to build it just like we built the other ones. Okay, so we'll start by putting on one of the end plates. I'm just going to line it up. Let's go ahead and crank these in position. So I'm going to make this the front of the actuator, and go ahead and slide our table on, and you can see we have our front mark here. Make sure you have clearance. Looks good. Go ahead and line the lead screw up and just hand thread that through. Let's put on our lock collar, 8mm shim, the bearing. And if you haven't done so, of course, you need to sand the ends down about 2 inches on the lead. And then go ahead and make this flush. Tighten down the lock collar. All right, that looks good. Now we'll focus on this end. Go with the lock collar again. We'll repeat the process on this side. Now, I still have this plate loose, so just set it on this surface here to get it kind of level before I kind of wrench it in place. And again, you'll see once we tighten this down, put this all in place. That looks good. So can't pull back and forth on that. That's good. All right, let's continue with the motor. Again, make sure you leave yourself a little gap there. On the motor, since this is the front of the machine, I'm going to have my circuit board mounted on the back beam here. And so I want the motor wires to come out and face this way, so I can have the shortest route. So it's going to sit like that. Okay, looks good so far. I'm just going to tighten down the flex coupling here. Make sure you tighten these down good so there's no slippage. All right, that looks great. Let's move on to the next step. So in this step, we're going to be building the side columns that will hold our X gantry. In order to do that, we're going to be putting 2 of them together like you see here and adding some bracing and some other of the cast corners. These are basically 2 500s that I've cut in half, so it leaves me about 248 or approximately 9 3/4 inches. You can see here. What we're going to do is basically just set them up like this. Just follow along. You can see in the front here, I have one in front of the other. And we're just going to set our cast corners right here on the sides. We'll just cinch this whole thing together. I'm using 10mm screws for this. So let's go ahead and do that now. Okay, so you can see here that I just have everything loose, nothing's really lined up. I'm going to go through and just get these close to the edge. They don't have to be right on the edge. I'll leave it about 1/4 inch or so. Like I said, they don't have to be exactly on there. So you can see something like that, and then we'll go through and tighten the bottom one to it. Just going to flip it over like this. Make sure we're even here on the face. Tighten this to it, and then I'm just going to go through and just wrench these in. And this is what we're after. So that looks good. Set that one to the side, and we're going to do the same thing to this one. All right, that looks good. We have our 2 columns, and you'll notice that if you look the way that they're built, you have 4 this way and 3 this way. And the way this is going to work is you'll have the 3 facing in the front and the 4 will be on the sides, like you see here. Our x-axis will mount right across there, and then the frame will also tie into these. That looks good for now. Let's move on to the next step. All right, on these columns, what we're going to end up doing is adding a couple more of the cast corners here as well as on this side. And this will help us later when we get into mounting the columns to the frame. So you're going to want to locate 4 of the cast corners, 4 T-nuts, and also 4 8mm low profile screws. These will be 8mm because they're flush in the track. So go ahead and get started with that and just show you where they're going to sit to the outside of the track here. Now we're just going to temporarily put these in place. This is not where they're actually going to stay. We'll adjust them down to the frame when we get to that part of the build. So just like you see here, and then we'll have 2 more on this side as well. Okay, so something like this is what you're after. And I just have the front ones lowered down a little bit more because they're going to mount to a lower part of the frame later. But that looks good. Let's go ahead and do the same thing on this column. Okay, that looks great. We have both columns built. Let's move on to the next step. Okay, so we have 2 500mm 20x60s, and these are going to be the bottom framework for our main portion of our frame. It'll sit just like this. We'll have 2 side beams here. Our columns will sit here. And so we kind of have to mark some things out here. On these are from a previous build. I'm just reusing them. So I just wanted to show you that I went through here and marked out the center. Since they're 500, it's 250mm here. And I just put a mark right there and just kind of got an idea of where the center is. So you want to go ahead and do that now. Another thing that's helpful is to put the y-axis on here and kind of center that, and then draw the side marks like you see here. And that'll give you an idea later of where you're supposed to be. And that's as simple as just bringing in the y-axis, laying it on here. And you can see here's our center mark here, and you can see that we centered it, and then we put our marks on like this. And then of course later we can go back and square everything up, but that'll give you an idea. So go ahead and center that, measure out 250 on these 2 500 frames and mark the center, and then we'll move on to the next step. Okay, so for this step we're going to need various T-nuts. So I just have a pile of T-nuts here. I have 6 8mm low profile screws and 6 cast corner brackets. Just going to kind of put things in place where they go, because we're going to need them later in the build. So first off, on this first track here, we're going to set a couple T-nuts in place. Though that will later be when we put our y-axis on here. The cast corners that come down to hold the y-axis in place, we'll use these T-nuts. And then in order to tie this assembly into the side frames that will be here, we'll need 2 cast corners on each end, just like you see here. So go ahead and put your 2 in here like I showed you here, and then we'll go ahead and put these on as well. We'll just mount these right to the edge. So go ahead and do that now. Okay, that looks great. You can see here that we have our 2 T-nuts for mounting the y-axis actuator. We also have our 4 cast corners for mounting our side brackets, and I just left them off the edge a little bit here. You do not have to tighten these down right now because they need to be able to cinch into the side braces, and then we can go ahead and tighten everything down. But for now we'll just leave it like that. One thing I was thinking we might want to do is just put an F here so we know this is the front. I'm going to put a B here so I know that that's the back one. All right, so that looks good. I'm going to move this to the side, and I'm going to bring in the back one, and we'll go ahead and start building this one. Okay, the back one is a little bit different in the way that things get connected to it. Of course, we're still going to need our T-nuts for the y-axis. So it'll sit here, and of course the L brackets will go here. But we also need a couple more T-nuts for our columns that are going to mount on here. So you can see I'm sliding a couple more, whoops, on the ends here. I'll take up the columns. And then we also need a couple to cinch the side braces into, like we did on the front bracket. So for those, we're going to be using the 8mm screws and the cast corners, just like we did on the front bracing. And put those in place now. And leave them a little bit off the edge, just like that. We'll do the same thing on this side. You'll see how all this goes together as we get closer to assembling the frame. Just make it like you see here. I'm going to lay these out real quick, like you see them, just so we can kind of get an idea of how they are going to be assembled with our front here and our back here. That looks good. Let's move on to the next step. Okay, at this time we're going to introduce two more of the 20x60, and these will be our side braces. You can see here how they will be assembled. They're going to go on just like you see here. I'm going to go through and add the T-nuts to cinch these sides up. So we'll have 4 T-nuts, 2 on each side. And these will be 10mm screws. So we also need 2 more T-nuts here, and as well as 2 more 10mm screws. So let's go ahead and put those in place now. I just want to interject something real quick. You know how we left the cast corners off of the edge a little bit? Now is when we want to loosen these up so that we can cinch them to the sides here. Now, you're going to want to line up the face like you see here, and then we'll tighten these down. And just kind of keep that together there while you tighten these down. Then we can go back and tighten these down a little bit more. It's like you see there. Now this one, I'm going to go ahead and loosen this bottom one, which I've done. And I'm going to tighten this one to the face. We're not exactly sure where this is going to sit yet, so we're not going to tighten this down too much. We need to find out exactly where this can be adjusted to. Then we'll go back and tighten it down. We can actually tighten this bottom one down and loosen this top so we can move this bar where we need it. Let's continue with this side. Go ahead and line up our T-nuts and do the same thing on this side. Again, I'm just cinching that down, loosening the bottom ones up here, and then tighten the side ones in place. And this just brings everything tight and close together just like you see here. And then we can cinch it down. Okay, that looks good. We have everything in place. We're still able to move this one and this back brace and adjust it to where we want. And what's going to happen is, you can see we have the extra T-nuts here. Just want to give you a quick idea of how this is going to go together. Kind of see when we bring the columns in here, the look that we're after. So we'll go ahead and start bringing this together and mounting these columns to the framework. It's looking really good. Let's move on to the next step. We're going to go ahead and lower these down. Just let them fall here, loosen them up. These 2 front corners. And then we'll just line up our T-nuts, and using the 10mm low profile screws, go ahead and put them in place. Okay, that looks good. And I just have these snugged at this point. I'm going to go ahead and turn this sideways. And we're going to do the same thing here. Just drop these down, and using 10mm screws, we'll go ahead and tighten this to the side here. I'm going to bring this whole assembly back until I am flush here on the end, and then pressing this down, making sure that I'm tight against the rail here. Go ahead and snug these in a little better. Go ahead and cinch them down with the short side of the Allen. Make sure these columns are tight. Now for now I'm just doing these outside, and then we'll go back and do the inside here. Okay, so we're going to do the same thing on this column. Go ahead and loosen these so they drop. And again, make sure you're lined up here on the edge. Take a couple T-nuts, 10mm screws, and tighten this down. Again, make sure that you squeeze this together when you actually go to tighten it in place. All right, that looks good. Coming along nicely. Let's move on to the next step. All right, now's a good time if you have a speed square or something that you know is square. Just go through and just check that you are square all the way around. And we look good here. So everything looks square. We're lined up on the back here. We can go ahead and tighten everything down now. So let's go ahead and do that now. All right, everything looks good. Let's move on to the next step. On this step, we're going to introduce the Y-axis to the frame. You can see here. And with our marks that we have here on the sides that we made, we're going to line it up and we're going to loosen our L brackets here and just slide those over until they're over top. And the main thing to keep in mind here is that the C-beam end plate that you see here should be to the end of the bottom brace like you see here. Just go ahead and line that up, and then we'll do these, and then we'll also do the ones in the back here, and we'll need 4 8mm screws to mount those. Let's go ahead and do that now. That takes care of the front. Let's go ahead and spin this around. We're going to do the back now. I'm going to go ahead and just move the table out of our way a little bit so we can work. If you feel that it's really hard to turn, just make sure you separate the coils, because if 2 of the coils are touching, it can make it tough to turn. We'll go ahead and loosen these up and align them. And again, make sure that you align to your sides. Make sure that you're square. If you want, you can measure from here over on each side and just make sure that you're perfectly square, and make sure that your distance is proper there. I'll go ahead and mount these with 8mm screws as well. So I'm a little bit off on this. I'm going to go ahead and loosen the 2 bottom screws here so that I can adjust it a little bit while I'm working on it. Now I can adjust this back and forth a little. I can see my marks. That looks good. Before I tighten these down completely, I'm going to double check my measurement here. Go through and tighten everything down now. All right, that looks good. Everything is square. We have our Y-axis on. Really nice. Let's move on to the next step. So we're going to be mounting this whole XZ assembly on here. But in order to do that, it's going to be a little difficult. I'm sort of reassessing the way that this mounts. And I think we should take these mounts and put them on here, so it gives us a little bit of a kind of a shelf to hold this onto. So I'm going to go ahead and take these corner brackets off of here and then mount them onto there. All right, so that looks good. Now what we're going to do is we're going to put our L brackets on here. We're going to want to use our 8mm screws for that. So I'm going to use 8mm screws, a T-nut. Just get it started, a couple turns, line it up, slide it down there. Just kind of guess where that goes for now. Just something like that, where it's down a little bit, so when we set it on there, it's kind of like a shelf. So I'm going to go through and put all 4 of these on. And they're going to go on the outside edge, outside tracks like you see here. Okay, that looks good. And now we can set our X-axis in place, kind of get an idea of where these need to be. I think our best bet would be to tilt this whole machine back. I'm going to spin it around, tilt it on its back, and it'll be easier to work with. Hang this over the edge of the table a little bit. And basically what I'm going to do is align these T-nuts and go ahead and get this mounted. And you can see we're trying to get the C-beam end plate even with the edge, just like you see there. So what you're going to need to do is get your 10mm screws, line up your T-nuts, and put those in place. And we'll go ahead and mount this assembly. Alright, so we can go back and kind of tweak that later, but let's go ahead and get this side while we're at it. And I am going through and making sure it's as flush as I can do there on the face here, but we can also adjust that later as well. For the time being, let's just go through and get these screws in place so we can get this assembly mounted. Alright, everything looks good here, but you can see that we're not even, we're not flush here or here, and of course we need to adjust this. So what we're going to do is bring our plates in, and these are going to sit on the top just like you see here. And you can see that we're going to use 3 self-tapping screws across the back, 3 on each side, and then 2 of the 10mm screws here. Let's go ahead and put our self-tappers in. Make sure your drill's on low and just go ahead and snug this plate on. Once the screws are in place, I can loosen these bottom brackets. This will allow me to tighten the X-axis actuator to the plate where it belongs. Alright, now everything is flush and even, just where it's supposed to be. We can go through now and tighten down these bottom screws and cinch them into place. Alright, that looks really good. CB machine is really coming together. Everything looks strong, everything is tightened down. Great job. Let's move on to the next step. On this step, we're going to be installing the L brackets that will hold the power supply. So I'm just going to jog this out of the way for a minute. And we're going to be installing them across this back track that you see here. If you take a close look at the L bracket, you'll notice that the holes, the spacing on the holes on the bracket are different. One is closer to the center. The one that's closer to the center is the one that we want on the rail. The one that's further away from the center is the one that's going to mount to the power supply. We're going to be using 8mm screws, low profile screws, as well as the drop-in T-nut. And just go ahead and put that on a couple turns, and then you simply drop it in and tighten it in place. And same thing on the other one, and we'll be able to move these around the rail where we need them. Put it on like so, drop it in, and then when you turn it, what happens is it spins 90 degrees and locks when it starts to tighten onto the rail. Okay, that looks good. Let's move on to the next step. Okay, for this step, we're going to install the spindle into the spindle mount, and I'm using the Bosch Colt 1 horsepower palm router. You could also use the DeWalt 611, but the Bosch Colt is what this mount was designed for. If you use the 611, you may have to shim the sides out a little bit, but it will also fit in this mount. One of the things I wanted to show you was we use a lot of the 1/8 inch bits, so I actually bought a collet for this that allows you to use 1/8 inch bit. It comes stock with a 1/4 inch collet. So I'm just going to put that on now, just loosely. Put this in place, and again on my machine, most of the cords are going to be going through the back here like you see. So I got everything going this way. One of the things I want to mention is if you look underneath here, this red button here, you want to be able to gain access to that, but you want this to be up as high as you can get it so that the collet is even sort of with the bottom here. And this is with the gantry jogged all the way down. I usually jog it all the way down and then move it back up about 1/8 to 1/4. And then just lift this up and kind of how you see what I have here, somewhere along those lines, and tighten it in place. You don't want to over tighten it. Something like that. Right, that looks good. It's not going anywhere. Let's move on to the next step. On this step, we're going to go over installing the software and plugging the board in and making sure all the settings are correct on the Gerbil board. So go ahead and get your Gerbil compatible controller. For this particular build, I'm using the X Pro controller, and I'm just going to go through and do a quick overview of how to set everything up. So go ahead and go to openbuilds.com, go to the CB machine build and download the files needed. And the two folders that we're concerned with are the CB machine software that I have here and the CB machine G-code examples. If you open up the CB machine software folder, you'll see we have a few different options. We have a Gerbil panel, we also have universal G-code sender, and we also have a G-code previewer called OpenSCAM. So for this particular build, I wanted to try something new that I haven't used before, and I downloaded Gerbil panel. Normally I use universal G-code sender, that works really well. But since I've installed Gerbil panel, to be honest, I really like the software. It seems to have a lot of nice features, and it will grow with us as we learn our machines. So I thought this would be a good one to kind of do an overview and get people started on using this software, or at least trying it out as an option. So we'll be using that for this video build. First things first, let's go ahead and double click on the OpenSCAM icon, and that will install OpenSCAM on your system. I'll double click it and put a little icon over there. OpenSCAM is awesome. It's a great G-code previewer. We'll take you through and show you exactly what you're going to cut out before you actually cut it out. Gerbil panel does not have a G-code previewer, so OpenSCAM is a nice companion to have with it. I'm just going to go in here and go to File, Open. One of the first things you want to do under supported file types here, drop that list down and click on All Files, and that'll open up the door to allow you to open what we have, which are .cnc files. So go ahead and browse to your desktop and look for the folder CB Machine G-code examples, and just go into, for example, Sketchicam aluminum examples. And if you look in there, you'll see there are some .cnc files that are examples. I'm going to go in here, I'm clicking on the aluminum OpenBuilds logo example. So if you look here, you get a cool preview of what this is going to actually look like before it cuts. And this way you don't make any kind of mistake when you go to, cut something out. So one of the things I like to do, and this is completely optional, but I'm going to go over here to the CB Machine G-code examples folder, and if I go into, for example, Sketchicam aluminum examples, and I find here that we have, among the SketchUp examples, we also have, the .cnc examples, like the 20mm plate examples. One of the things I like to do is right click on that and hit Open With and browse under More Options till you find OpenSCAM. And what that'll do is that will associate your .cnc files with OpenSCAM. So now when you double click on an example, it just goes right into OpenSCAM and allows you to see, what you're going to cut out before you actually cut it out. So that's really nice to do. Like I said, that's optional, but it's just a nice little feature. I'm going to close these out. And we're back in the CB Machine software folder. Okay, we have OpenSCAM installed. We've associated the files with our .cnc files with OpenSCAM. Now I'm going to go in and I'm going to set up Gerbil panel. Now, Gerbil panel, if you double click on the directory there, open that up. If you look in this group of files, you'll see Gerbil panel application. You're going to want to right click on this and put send to, and then click desktop. And you'll see that it sends an icon to your desktop. Now we can close this folder, and I actually have already done this, and it's over here, Gerbil panel shortcut. So we have a shortcut now that we can double click, and it takes us right into the program. And immediately upon opening, you can see that the program is set up really nice. We have jog buttons here. We can actually adjust any jog distance or feed rate here. We have our machine offsets as well as our work offsets. And if you click here, there's a tab up top where you have all of your settings, and this will be populated with your Gerbil settings once the board's plugged in. Let me go back to interface. So one of the first things we're going to do here is maximize that. I'm going to go ahead and plug the board in and just give it a minute. It may take a minute for your computer to set up the USB, and go over to the COM port, and your COM should come up once you drop the arrow down. Mine here is COM 3, so I'm going to click that, and then I'm going to click the connect button here. And as soon as you do, the board lights up. It starts to read the Gerbil firmware that's been uploaded to the chip, and you can see that it has all the buttons are now lit up. So let's go ahead, and what we want to focus on is the settings tab. Now in the settings tab, you'll see a list here populated with ID numbers and their values and what they mean. For instance, your steps per millimeter. We have to set all that up for the machine that we're using. In this case, we're using the CB machine. And it's really simple. You do this once, you set it up, and then you never really have to mess with it again unless you really want to fine tune it, or you want to add limit switches or something like that. Yes, you can go back in here and mess with it. But normally once you have this set, there's no reason to mess with it anymore. What we've done is we've put together some example settings for you to follow, and I'm going to go ahead, let me bring this down a little bit. I'm going to snap this window to the left pane here, just so I have it there. And then I'm going to open up the CB machine software folder again. And inside that folder, you'll see a JPEG entitled CB machine settings. If you double click that, I'm going to go ahead, I've already done it here, but just to show, I'm going to drag it over here, snap this to the right hand side. And what that does is it allows us to work on these settings side by side, because what we're trying to accomplish is to copy our example settings over to the actual settings on the board. And what happens here is we go through, again, this is a one-time deal. You just go through, make sure that all the numbers match, and everything should look exactly the same. And the way that you do that is, let me give you an example. Scroll down here to 100, which is the X steps per millimeter. It's set up right now at 200 steps per millimeter. That's actually correct, because we're using lead screw on all 3 axes and our board is set for 1/8 steps. So that's actually correct, but I want to show you how to change the settings. So if you look here, I'm going to go ahead and click here, and I'm going to type 100. And if you notice to the left here, it changes from an arrow to a pen, which means you're editing it. And then we're going to double click in this area and click out. And what that does, you can see it refreshes, it sends that to the board. There's a button down here that says Get Gerbil Settings. This will also read the current settings from the board. One way to make sure, once you have your settings in there, just to make sure that they're actually in there, is you can go over here and hit Disconnect under the interface tab here, and then hit connect. You have to wait a minute for it to load. And then if you look, you'll see that our settings have changed now. If I go down to the 100, and now it's at 100 steps per millimeter. Of course, that's not what I want. This is just an example, so I'm going to change it back. I just want to show you how you send the settings to the board. So I'm going to go ahead and click in there, type 200, and double click, so you can click out of the editing mode. And go ahead, we're going to go back, and there you can see it refreshed. But just to double check, again, I can disconnect the board, reconnect the board, go into the settings, wait for a refresh. So it takes a little bit. And you can see it refreshed, and now our 100 is 200 steps per millimeter. So you can go through and actually change all the settings that you want, double click out of there, and it will send it to the board. And then again, just to check it, you can go through and disconnect and reconnect. All right, so go through and set up all your settings. And once you have all those, we can get out of there. And again, you can always go back there and tweak those, and I'm sure you'll want to. One of the things I want to show you is over here we have enable keyboard arrows. Go ahead and click on that. That's really handy because it allows you to jog your machine using the arrow keys on your keyboard. Also, you may want to do metric jogging, which I do, so I have it ticked here. There's all kinds of other features that we can get into as we explore and grow with this program and learn the machine. But for now, we're just going to leave everything else defaulted. I'm going to go back to the interface here. I have the jogging distance set to 10 and I have the feed rate set to 500. If you look here, we have our software coordinates, which are all set to 0, 0, 0. And then underneath we have our machine coordinates, which are underneath there, you'll see 0, 0, 0. Whenever you're starting a cut, it's very important to know that everything starts at 0, and then unless you have special work offsets. But for what we're doing right now, we just want to make sure every time we start a cut, everything is at 0. And just to give you an example, the 0 point on this CB machine is the bottom left-hand corner here. This is 0, and anything out into the field is going to be into the plus direction. Plus 25, plus 250. You know, anywhere you jog out into the field is going to be the plus. And anytime you're coming back into the negative to 0. So I just want to touch base on that because it's important that you understand that's where we start. You know, the workflow is that you set up your piece, you jog the machine to 0, you touch the bit to the top of the material, and then you run the G-code once you double check that everything is zeroed out. All right, so that looks good. The next step, I'm not going to put the board on the machine right now. I'm just going to go through and wire all the stepper motors up because we have long enough leads to do it. We'll go through and we'll wire everything up and just test it out, test the software a little bit, make sure all the settings are working, make sure everything's jogging right, and then we'll go through and mount the board and the power supply and everything to the back of the machine, and then we'll get closer to having a complete machine there. So let's go ahead and do that now. First thing I want to do is disconnect, and then we're going to pull our USB cable out. Okay, so that looks good there. So on our next step, like I said, we'll wire up the stepper motors and we'll take our first steps. All right, so for this step, we're going to go ahead and wire up our card off of the machine, and we'll go ahead and wire up our stepper motors and just make sure everything's working, testing the software, and once it's all set up, then we can install the controller and the power supply on the machine at that point. You'll notice I have a 12-volt power supply here. You could also use 24-volt. I also have a wire pigtailed here at about 5 inches long, and if you look here, you can see I have it wired to the positive and to the negative, so that'll give us our 12 volts. One thing I want to mention before we even get started is you never want to disconnect or connect any wires to a controller board while there's power to it, because you can easily fry the chips. Once you take the power off, you're free to, wire, rewire, whatever you want to do. Just make sure you turn the power off before you mess with the board at all. So, of course, we don't have any power to the board. I'm just going to set this up. Because I have such a short pigtail here, I'm going to set it up like this. And I'm going to go ahead and, at this point, wire up the power supply to the board. On this particular board, you'll notice we have our ground and our positive. And on here, I set it up so my positive is the copper wire and that the ground is the silver wire. So I'll go ahead and wire that up now. Okay, that looks good. One thing I'm going to do is take a piece of tape, just tape this wire to the paper here, and it'll just help everything kind of stay where it needs to be while we're working with it. So we have our power supply hooked up. What we'll do now is I'm going to spin the machine here so we can access the stepper motor wires, and we should have plenty of lead here to go and hook everything up. So if you look at your controller, there should be a label somewhere on each one of the motor inputs. On this particular one, this block here is for X, this is for Y, and this one's for Z. On this particular card, there's a couple extra connection points for limit switches. We're not concerned with that. We're only concerned with the 4 connection points for each one of our stepper motors. I guess we'll start with the Y here. You'll notice that these are bipolar stepper motors and they have 4 wires coming out of them. So the first thing that we want to do is locate the coils in the stepper motor. The way it hooks up to the board is coil 1, coil 2. So we have to locate which 2 wires are coil 1 and which 2 wires are coil 2. An easy way to do that is, you'll notice if you keep the wires separated, you can spin the stepper motor freely. If you connect any 2 wires that are a coil, for instance red and green, just hold them together, you'll hear the resistance from the coil being shorted out. So obviously that's one coil, and what's left over is going to be the second coil, which is blue and yellow in this case. So now that we have our coils, we can go ahead and attach them to the board. All right, so we also have a reference drawing to the CB machine that shows you all the axes in relation to what direction they should be going. And we're just gonna print this out and kind of use it as a reference as we need it, so that after we hook up our stepper motors and we jog the machine around, we'll know that we're headed in the right direction. If we're going in the wrong direction, we can easily swap either one of these coils and it will reverse it. Let's just continue what we're doing. We're hooking up the Y-axis. So let's go ahead and hook that up now. Okay, that looks really good. We have our Y-axis hooked up, red, green, blue, and yellow. That takes care of that. We're going to go ahead and locate our X-axis, which if we look here, X is the machine left to right. That's this stepper motor here on the end. And we'll go ahead and hook this one up the exact same way. We'll have our red, green, blue, and yellow. And we'll hook it right into the next port here, which if you look says X. We'll just simply hook that in. Let's go ahead and do that now. Okay, that takes care of the X-axis. That looks really good. The next one we'll be hooking in is the Z-axis, and of course that's our up and down. I think what I'll do is go ahead and spin this circuit board around so we can hook it in a little easier. Alright, so at this point we are going to hook up our Z-axis, and on the Z-axis you'll notice that the plus is in the up direction on the example here. So in order to make that happen, we have to actually reverse the way the coils are hooked up. So on this particular setup on the Z, the colors are going to be yellow, blue, green, and red. And we'll start with the yellow on the A1. Let's go ahead and do that now. And again, if you're using different stepper motors or different motors with different color wires, no big deal. You can swap the two coils and reverse it, as well as reverse it in the software. So that looks good. We have everything hooked up. We have the three stepper motors hooked up. We're pretty much ready to go. I'm going to go ahead and turn this machine around at this point. Okay, that looks great. The machine's turned around, everything's kind of set up. Just kind of get your wires out of the way, and just so you can kind of move things around a little bit here, because we're going to take the first steps. So first thing we're going to do is plug in our power supply. And you can see the board lights up, there's power. And then we're going to go ahead and connect our board to the USB and go up here to connect and connect the board to the computer. Okay, we are now connected and we already have our settings on the settings page taken care of. We're going to go ahead over to the interface page and just make sure that on the jogging you have 10 and on the feed rate you have 500. So we just want to make sure that, for instance, our X, when we press it, moves to the right. So I'm going to go ahead and press that now. And you can see it moves to the right, so we're good on that one. Let's go back, let's go ahead and move it back to 0. You can also see that it moved 10 millimeters. So let's go ahead and move it back. All right, now we're going to go ahead and test the Y. So the table should come forward if we do Y plus. And you can see it does. Go ahead and move it back. Everything's still zeroed. And last but not least, we'll test the Z and make sure that it goes up when we press the Z plus. And it does. Bring it back down. I'm going to move the Z up a couple times here. There we go. Just give us a little bit of space under here so we, when we're testing and whatnot, we're not going to run into the bottom there. And as you can see, we now have 30 here. So we also have 30 on the work offset. So what I like to do is just disconnect when we want to zero this out and reconnect. And that should zero everything back out, and it does. You can also hit 0, X, Y, and Z, and that'll send the 0 command. So this is great. We have all the stepper motors hooked up properly. Everything's moving in the right direction, so that's a really good start. Let's go ahead now and we'll kind of jog this over to that far right position. One of the things I'm going to do first is under feed rate here, I'm going to switch from 500 to 1,000 just so we can get a little more speed out of our jogs. And then we'll jog the machine over to this far left position here. So let's do that. One thing I want to mention is do not hold your finger down on the keys, or on the buttons, or even the mouse, because it's kind of like a sticky key and it'll just keep adding up and compounding until it runs out of space. If that happens, no worries, just turn the power off and then turn the power back on and hit the reconnect button at the top and you can continue. So it doesn't matter where the zeros are at this point or where the digital readouts are at this point. We're just going to keep working our way over. And I can see that maybe one more. All right, we're about right here on the edge with the spindle. So now we need to move the table back. Just keep an eye on your cables here. And we'll go ahead and move that back. Now, if you hit the back, you don't have to be super worried about it. It will just stall the motor, but of course it's something you don't want to do as much as possible. Right now we're just trying to get a feel for the machine and see how it's going to work. You may be able to see that we're very close to the stepper motor, but this table can actually continue to go back even further. So you can actually take your finger and jog it back even more. And you can reach under there and jog it back, and you want to where it bottoms out on the plate, and it's right there. That leaves about quarter, maybe half inch. So that's really good. If I look at where we're at here with our spindle, we can see we're in that far corner, far bottom left corner, and this will always be our 0 point. We can also jog the Z up and down and kind of see where we're going to be, but this is roughly where we want to be. So go ahead and jog your machine to that point. Let's go over here, and you'll notice if you hit the 0 X, Y, and Z, it zeroes everything out, but it doesn't zero out the work offset. So you want to go ahead and just hit disconnect and reconnect. That's the way I've found so far in this software to zero out the offsets. Now, I'm sure there's another way, but just a real quick way to do it is just disconnect and reconnect. That works really well. So, okay, we have it zeroed. Okay, you can see that it brought back our 0, so let's go ahead and hit 0. We want everything zeroed out, which it is now. So at this point, we could actually load a little bit of example code. I'll go now, and let's see. I am in if you go browse to your desktop and look under the CB machine code G-code examples folder, which is one of the 2 folders that we brought in there. We have Aspire example codes that I did a few examples in Aspire, Sketchicam aluminum examples, Sketchicam pen draw examples. Now the Sketchicam pen draw example codes, let's go in there because they're designed for a pen holder. And the idea is that you can attach a pen holder here to the side and draw different things that you want to draw. It's a good example because the Z-axis does not move up and down a lot. So we'll go ahead and use that as our example, and we're going to pick one of them. We have ink circuit lower. The Indian head is a pretty good one. It has a lot of different movements in it, so this will be a good one to test. It's called Test C-Beam Code Ink Indian Head. So if you click that, click open, give it a minute to load. And you can see here that it is already loaded, and this is our first real G-code that we're running through it. So just make sure you're zeroed, just like you see here. So this is it. Let's go ahead and hit play, and let's see what happens. And the play button is right here. Wow, it's really doing a good job. You can see the digital readouts going through the paces. You can also see the code scrolling. It buffers a lot of code really fast. It's a nice program. All right, I'm going to go ahead and hit the stop button here. And you'll notice I hit the stop button, but it didn't stop right away. It takes a little while because it needs to scroll through the lines that it had in the buffer queue. Everything's running nice and smooth. If you hear any rattling or anything, now would be a good time to kind of go through and tighten down something you might have forgotten to tighten down, or square something up, or any of those types of tweaks. So here we are, we're jogged out into the field. As you can see here, the bit is out in, just randomly out in here where it was working on the design. What we want to do is bring this back to the 0 point. And the way you do that is, in this software, there's different, what they call special positions. And this position is the 0 position. So it's defaulted that the go-to special position 1 is X, Y, and Z 0. So we can actually click on that and it should bring the spindle right back to 0. So let's go ahead and click that now. And there it is. Now we're on 0 on all of our readouts. Everything looks good. We've run our first G code. It's awesome. Congratulations. If you've made it this far in the build, it's going to get a lot more fun from here because now we can start creating things. Before we get into cutting out different parts and pieces, you have to kind of make a decision at this point. I'm going to give me 1 second. I'm going to disconnect right up here, and I'm going to turn the power off to the board and disconnect the USB. All right. So we need to decide at this point, are we going to have a standalone box that sits out here and the wires run out to it for our controller and power supply, or do we want to mount it to the machine so it's kind of we can move the machine wherever we want in the shop and all we have to do is plug it in. On this particular machine, I want to make it semi-portable so I can just move it around. What we're going to do is we're actually going to mount the power supply to the back as well as the circuit board. I have a plate I actually made that fits the back of this. I cut it out of plexiglass and I drilled and tapped some M3 holes to hold the circuit board to it. And the idea is that it can actually mount to the back here. So you could make something like that. We actually have that plate shared here in the example G codes, and I believe it's under Plexi board holder. This is basically what it looks like here and allows me to mount the board right to it. So it's a really handy little mounting board. So I'm going to go ahead and like I said, I'm going to mount mine this way. You do not have to do it this way. This is kind of where you go and make up your own thing. Some guys use a Tupperware or a project box, and you can mount that right on the back too. You can mount it anywhere you want along here. You can even put it under here if you wanted to. There's all kinds of cool things you can do with this machine. This is just the base unit of the machine, and I'm sure as it's posted out there, it's going to grow into a really cool plate maker. So let's go ahead and we'll move on to the next step of mounting the electronics to the back of the machine. All right, so first things first, I'm going to go ahead, of course the power supply is off. I'm going to disconnect the power lead here from the board so we can work with it. We're separating the power supply. Now, all of these wires we can actually leave on here. There's no reason why we would have to take these off. I'll go ahead and spin the whole machine around so we can work on it from the back side. So we'll go ahead and do that now. Okay, so the first thing we want to do is take our power supply and mount it to the back of the machine. I already have a couple of the single L brackets here, and what I need to do is actually jog. I'm going to hand jog the machine, the X-axis out of the way so that we can get the tool in there to work on the power supply as we mount it. If you take a look at the power supply, the way we have it set up here, we're going to be mounting it on these two holes, and we'll be using the M4 6mm screws to do this. You'll notice that the holes on the brackets are, this side in particular is up high. So just go ahead and mount your power supply using the M4 screws. Okay, so you can kind of see here what we've done. So just kind of match what we've done here And like I said, loosen these up because you want to slide this whole power supply unit as far as you can to the right. Just mirror what we've done here. All right, that looks good. Our board is going to mount as far to the left as we can get it and right to the back of the C-beam, just like you see here. So what I really would like to see is all of my cables coming off of this one column on this side, but we'll see how that works out. Here is the little plate that I've made using a couple 8mm screws and drop-in T-nuts. You can see that you can mount this. You could mount it this way, anywhere you want it. You could also mount it this way. It can mount either way. And I also put some 1/8" spacers I just super glued over the holes that I've tapped. Mounted on just like you see here with some M3 screws, and that'll be great. All right, so let's go ahead. We'll put this in place. Okay, that looks good. We'll take our M3 screws and mount this on. All right, that looks good. One of the things to continually check is just to make sure that your wires didn't move or come loose or anything like that. Now, our X and our Y wiring, I'm going to kind of just push these into one of the slots here. Again, I'll probably come back and do a coil wrap on these and just make them look really nice. The Z, however, is hooked to this gantry, so it has to move back and forth. So we are going to have to do something that allows this to go the full gambit left to right. So for now, I'm just going to push it in there a little bit and kind of keep it to the side. And then again, we'll come back and work on it and make it look nice. But this works right now. Our power supply wire, one of the things I wanted to show you, I found some of these cable connectors. These are just 1/4" cable connectors, and I was able to put an 8mm M5 screw through here and just put a drop-in T-nut. What's cool about this is you can put it anywhere you want along the path of the V-slot and tighten it down in position. And it just makes it really easy to do any kind of a wire run. As you can see right there, that looks great. And I have a couple of them on this one so I can hit the bottom as well. So I'm just going to take some of the extra wire, wrap it up a little bit, do a little cord management here. All right, that looks great. The only other wire we're concerned with is our router wire, which again, I will route to this side. The router wire also moves back and forth, so you may want to put a clip up here, for instance, and, you know, kind of chain these two wires together. I'm going to lay mine here for now. It's really good. One last thing we need to do before we move on is to reconnect the power supply to the board. Let's go ahead and do that now. Keep in mind which is your positive and which is your negative. We'll go ahead and reconnect that now. Okay, that looks good. I'm going to push this into the track right here a little bit. I do like the ability to just kind of hide things in these tracks. Make sure you're connected well. Everything looks good there. Let's go ahead and spin the machine back around. All right, at this point, I'm going to go ahead and plug the spindle in as well as the power supply. The reason why is I want to make sure that we didn't over tighten our clamp to the router. We want to turn it on and make sure it runs smoothly. All right, everything looks good there. All right, let's go ahead and turn the power back off. Power is off, and now we can plug in our USB. Okay, everything looks good there. Nice, neat. I really like the layout of it. Jog this back over. Get this kind of lined up to our 0 position. Again, kind of lining this up with the edge of the table. Plenty of room over here for later options. Maybe we can have tool changers or something like that. It'd be really cool. Bolt it right into the side here. You could pick up different tools. That would be a fantastic mod for this machine. So here we are. Everything is put together. It looks great. So let's move on to the next step of actually running some example codes and seeing real world output. All right, so at this point we're ready to do our first Hello World cutout. Normally you'd attach a pen here and you would draw something, but I thought it'd be just as good to just attach a piece of foam here and cut something. So we're gonna go ahead and do that. That'll be our Hello World piece. And also thinking about the fact that a lot of you guys may not have this collet, the 1/8 inch collet yet. I'm going to put the 1/4 inch collet back in. So that's the stock collet that comes with this particular router, the Bosch Colt. And I went ahead and bought an inexpensive Skill 1/4 inch, just like a straight mortising bit. See here, it has 2 flutes, and it's just a standard router bit, and this should work fine for what we're doing. I've gone through and let me go ahead and put this in here. Remember, you have to hold the red button on the side. I'm just going to hand tighten that for now, and I'm going to lower this down and just make sure that it's low enough. If not, I may have to lower the router a little bit. As long as it can touch the spoiler. Yeah, see, we're good. All right, good. So I can go ahead at this point and take my wrench and I'll tighten this down a little bit more. Here's a little spanner wrench we made just for prototyping purposes on the original CB machine as we worked it. Okay, that looks good. You don't have to over tighten that, just, you know, lock it on. All right, so for this code that we're gonna run, we're gonna use a piece of this project panel. I just got this at my local hardware store. They actually sell it, I think it's 2 foot by 2 foot sections, and I cut it down to 1 foot. And so we can fit it on the top of the spoiler here. We have our 1/4 inch bit in here. It's very important that you do not try to run this code with wood. Go out and find foam. This code is designed to run pretty quick, and it doesn't have enough step downs to cut through wood. So make sure you use foam only with this particular code. When we get into wood, we'll be doing multiple step downs to kind of work our way into the wood or aluminum. So I just wanted to let you know to make sure you get foam. This is inch thick foam, but you could actually use 3/4 inch. You don't want to use anything smaller because it's actually set up to cut about 1/2 inch into the foam. So you definitely don't want to go any less than 3/4. So we'll go ahead and get ready to do our first cut. We'll go ahead and hand crank this up out of the way. You can use things like double-sided carpet tape, which is a real thin tape that you could put on here. You could have clamps. In fact, there's enough room on the sides here, you could have little clamps on the side. I think might actually make the clearance. But for now, I mean, just for this test cut, it's just a Hello World, just to let us know that we're bringing the code out into the real world. We're just going to take tape and we're just going to tape it on there. So let's go ahead and do that now. All right, that looks good. We have it taped on there. You're going to want to go ahead and jog your y-axis here back. Just reach around underneath here and jog it back until the plate hits right there, and then should be good there. We'll jog our X over here, trying to get it lined up with the corner here or close to it. You know, bring this down a little bit. So right in there looks pretty good, and I'm just gonna bring this down just a touch here, barely touching the foam. Okay, it's touching the foam. I'm going to turn we'll make sure I have the power on first. There we go. I'm going to turn the router on for a second. I can see I'm touching the foam there. And that looks pretty good. I can see this bit is not the greatest bit in the world. It actually has some run out to it, but that's all right. Like I said, for just testing purposes, just trying to get our first actual cut going, this is going to be great. Make sure your wires are not interfering with anything, that they're not going to, you know, catch or anything like that. All right, that looks good. We're ready to give it a go for the first test cut. So I'm going to go over here. I'm going to hit connect. Power is on, USB's connected. We've got a sound connection there. Let's go ahead and open up a folder. And we want to go over to the C-beam example code. And in there, you'll find a folder called Sketchicam Foam Example Hello World. Click on that, and then click the .cnc file. Hit open. And one of the things I want to mention, most of the time I use an 1/8 inch bit. You can even use a 1/4 inch to 1/8 inch, where it kind of tapers down to an 1/8 inch. But most of the time, most of the bits that I use are 1/8 inch shaft. So like we would be using the other collet. This particular code is set up for a 1/4 inch. So this is kind of unusual. It's not going to be super high detailed or anything like this. I just wanted to make sure that we were able to actually cut something out before we got into the other detailed work. So that's why I'm sticking with the 1/4 inch bit and 1/4 inch collet. I think I'm going to scoot this over just a hair to get it in the playing field here, and that looks good. The way this is going to work, at this point all we would have to do is hit play and watch it. But what we're going to do is turn the router on, and then we'll hit play, just so you know what's happening. You may want to get a little shop vac and kind of keep it vacuumed. So I'm going to go ahead and grab that now so I can do that while it's cutting. All right, so let's go ahead. We're going to do our first cut now. Turn the router on, starting the code. I'll start up the vacuum and try to keep it as clean as possible in here. So let's get started. All right, the cutting is complete. Let's go ahead and we'll jog the Z axis up, out of the way, and then we'll jog the Y axis plus towards us. Check it out, that came out really cool. There's a couple little artifacts there, but that's just like in the code creation. All in all, it's super cool. You've made your first Hello World cut. So the machine is alive. It actually produced something in the real world. And now we can move forward into learning a little bit about how to make a creation and actually cut it out. I'm going to go ahead, and at this point I'm going to move everything back to 0, but you can see we jogged it out here just so we could look at it, but also so we could take it off of here. So let's go ahead and remove the tape, and we'll take our first cutout off of here and save it for life. So again, that looks awesome. All right, that's our first cutout. That looks great. Let's go ahead, and while the machine is still powered up, we'll go ahead, and you can see we're jogged out into the field here. We're going to go ahead and move this all back to its 0 position. So I'm just going to go to special position 1 right here. Okay, so that was our initial starting position, because you remember the foam is 1 inch thick, so is up this high. That's basically where we're going to call 0. That looks great. Let's go ahead and move on to the next step. All right, so we have the C-beam machine built. The only thing missing at this point is just to add a little bit of bling and do some cable management in the back, and we're good to go. If you look at the model, you'll notice that we have plexiglass side plates, and these are just to help kind of keep the debris out. Once again, this is just something I'm doing for my build. You may want to enclose the machine completely. It's up to you. I also have added a few of the slot covers here. We've added a few of the slot covers to kind of keep debris out. You could create a billows systems here if you wanted to keep debris out, but that's up to you. Again, this is just what I'm doing for my build. So if you go into your miscellaneous folder, you'll find this picture's in there for reference, as well as the C-beam machine side panel picture, and this will give you the dimensions that you need to actually cut these side panels out. Of course, you only really need to cut one out, and you can use that one as your template to trace the other one to it. I purchased this sheet here at the local hardware store, and it's 18 by 24, and it gives you plenty of plastic. It even comes with like a clear coat on there that you peel it off after you're done cutting. So I'm going to go ahead, and I've already marked all this out. I'm just going to take my jigsaw, cut this out, and drill these holes, and then I'll trace it and do it again, and I'll have 2 side panels. So I'll get started doing that now. That looks awesome. Let's put some end caps on here and on the top here. Okay, so we've added the bling. We have our slot covers on here. We also cut out our plexiglass side plates that you see here. Looks really good. I'm real happy with it. Like I said, there's a lot of different ways you could build this machine. This is just an inexpensive way that we've come up with. You could add double Y-axis here if you want extra strength. You could add double X-axis if you want, different Z configurations. There's a million different ways to build it, but this is just a great example of how to build a really nice machine out of stock OpenBuilds parts. The CB machine is going to be an awesome tool for our shops to be able to cut out all kinds of different plates and just really prototype ideas in the real world, and this machine can do it. So we really look forward to seeing all the great builds you guys come up with using the CB machine and take your builds to the next level. So we hope you enjoyed the build. Please stay tuned because we're going to be using the CB machine to cut different projects out of wood and out of aluminum, and we'll be posting videos of how we go about doing that as well. So keep an eye out for that, and thanks again for watching. Congratulations. Please post your builds to openbuilds.com so that others can share in the excitement of your builds. Thank you.